Well, microphone, there we go. All right, welcome to 4 p.m., Derbycon, track 1, Friday. See, I know where I am, when I am, etc. My name's Joff. This is Derek Blanks. We are both Black Hills Information Security employees, and we're here to talk a little bit about Android app penetration testing 101, just because we wanted to do something a little bit different. Okay? Who am I? That's a good question. I sometimes wake up in the morning and wonder that as well. My name is Joff. I'm no longer on the screen. I'm on the Twitters as @Joff_Thayer. And I'm hoping that the AV works in this talk. All right. Thank you, Adrian. There it is. Oh, that's it. All right. Back. I'm in the frame. All right. So, also, security researcher, sometimes pen tester, Black Hills InfoSec. I am also the instructor, one of 3 right now, for Sec 573, which is automating InfoSec with Python. Do yourselves a favor and learn Python as a programming language. It will do amazing things for your information security career, and I'm not joking. I'd love to have you in my class when I'm in the United States. I've taught mostly in Europe this year, but that's fun anyway. Co-host on Security Weekly. Any Security Weekly fans? There we go. Woohoo! All right. Also, born in Australia, adulting the USA, well, that's sort of questionable. And musician, geek, dad, middle-aged. I was laughing, these guys talking about being old. Was anybody in Paul's talk? He's like, oh, I'm so old. I'm like, dude, I'm 10 years older than you. Right? Stop that. All right, so that's about me. Derek.
Hi, I'm Derek. I don't do any of that stuff. No, I work at Black Hills too. I am a holder of multiple certifications, none of which you guys care about at all. So, oh, sorry. See, that's what happens with the muscle relaxers. I can hear myself, right? So I was hoping that Joff would spend the whole talk down there. So on video later, it would just be me standing here and words and me just looking around. But
right.
So how many of you folks are from Virginia? The coast of Virginia, like Tidewater area? Oh, sweet. Come to my meetup once a month. We usually have it at a bar and, talk about InfoSec, and everyone is welcome. And I'm also an avid OA enthusiast. Does anybody still use OA? Yeah, I don't believe you.
Is that a boat?
I know people still do.
Is that a boat?
So, Office web app, right?
Oh.
Sweet. And that's pretty much it about me.
And so he's 0x Daruk on the Twitters if you want to follow Derek, and he does some wicked smart things at Black Hills. Actually, we like to think we all do some wicked smart things. We like to publish what we do quite often. If you have not visited the Black Hills Information Security blog and our webcast postings that are on the website, you should do so. There's actually some really good stuff there, and I'm not saying that just because I did some of it. Everybody in the company really is encouraged to write, and I think it's a very good thing for us collectively. So go check it out sometime.
Also, stop by the booth. There's free T-shirts.
Free T-shirts, right. Okay, so let's get to it. What's our agenda? Well, who cares about Android apps?
Everybody that raised their
Everybody that raised their hand a minute ago, right? Some testing environment considerations and tools. We're going to talk a little bit about methodology of testing, things like file system behaviors, network behaviors, application issues. We're going to talk about an example attack, and I'm going to go through a little segment of embedding some malware in Android package files, which is kind of fun. And then I will drop a tool. Sorry. No, I'm not going to be sorry. The only reason I'm going to drop a tool is because I hated the section on embedding malware, and I was like, this is way too complicated. This has to be automated.
There's only 47 manual steps.
Yeah, only 47 manual steps.
And he's going to do it as a demo.
Yeah. Watch me. You have to hold my beer for that one. Okay. So, why Android? Well, because the Apple iOS guys have 5 guys in a cave. I didn't make up that statement. That's courtesy of Josh Wright. 5 guys in a cave mean they're guarding the gates from malware, right? And they're trying their hardest to maintain this security paradigm, which they've done relatively well at. Great, good for them. Stuff still sneaks through, but, that's the case. Unfortunately for them, they are not the majority of the market. Android, there are over 2 billion Android users on this planet. That is huge.
It's terrifying.
Microsoft, did anybody buy a Windows phone?
But
I don't see any hands, right? Yeah, only to hack it, right? Because it was Windows. And victimizing Windows is just, well, it just feels right.
Yeah, I know we're talking about mobile, but does anybody know how many Windows installs, like Windows 7, Windows 10 installs? And I got these stats off the internet, so I know they're true.
Because everything you read on the internet is true.
So, yeah, exactly. So 2 billion Android users, and there's 1.25 billion Windows installs. So, hey, Linux did win.
That's a big deal, right? All right, and open marketplaces are exploitable. Yes, we have this thing called an open marketplace. We can write stuff and throw it up there. We just need a signed APK file, and as I would like to say, Bob's your uncle, and you're in, right? Okay, Android wins, right? The market share is huge. That's why Android. What about the Android operating system? Okay, this is interesting. Thanks to our friends at various telco providers, virtually none of you have an up-to-date Android operating system, especially if you're locked into your, Verizons or your T-Mobiles and so forth. That's why I bought a Pixel and then I bought a OnePlus 6, because I was sick of that world, right? I wanted to run the latest Android. So most of you are going to be somewhere between Nougat and Marshmallow here, or Lollipop. You're going to be in the 6.0 to 7.0 release, when really Android's running Oreo these days, right? And so the market share is definitely bent towards the stuff that's not the latest and greatest. Okay. So it is, right? And this was stuff I pulled off a web page, because everything you read on the internet is true, July 23rd, 2018, when I was starting to put this presentation together. All right. What about the risks? Anybody got some enterprise data on Androids? Well, yeah. Right? Are you reading your work email on your Android? I'm thinking you are. Okay? Poorly written apps? Yep. Debugging capability enabled in apps, right? That's a big deal. It happens. Library dependencies with vulnerabilities. Amazing. It happens in the mobile space all the time. And of course, malicious apps, sidejacking and redesigning legitimate apps, right? And we can affect a large number of people. It's kind of a fun space. Android's a very trusting world. When you get into the Android operating system, it's like everybody loves each other. It's beautiful, right? There's this Java virtual machine environment, and it's like, hey, you want to send me a message? Okay, send me a message. That's cool. I'll receive your message, and I will do something based on that message. It's like free love in an Android world, right?
We have a story about that later in the slide deck.
Yeah.
By the way.
All right, so you want to hack mobile, because you wouldn't have come to this presentation if you weren't interested in a little bit, right? Overview. We got to have some software tools. We have sort of the essential tools, and then we have the nice-to-have tools. You definitely need an emulator or a hardware device, okay? You definitely need to get a hold of apps, usually APK files. You probably don't want to download those from the Android Google Play Store. You actually want the Android package files themselves, right? And there's ways to get those. We'll talk about it. You want to be able to sideload and debug against that Android, right? And it turns out the emulator is really cool, because if you were to install the full Google development suite, which most of us are going to do, you end up with an emulator to run any version of Android that you want to run, all the way back to API 20-something. It's up to about 25, 27 now. And you end up with a full development environment that you can fire off those emulators and do whatever you want with. And you also end up with this cool tool called ADB, which is the Android debugger, that you can communicate with the emulator. Okay? So the must-have tools beyond Android Studio and the emulation environment, you need JADX and JADX GUI. This is the popular tool for decompiling Android package files. Okay? What we're going to do with JADX and JADX GUI is we're going to take an Android package file, we are going to decompile it into the Smiley-based assembly code first, which is kind of, Smiley is the assembly code for Android, and then we're going to reconstruct the original Java source based on those Smiley files we generate. We're essentially reversing things, which is great. Very, very useful. You also want AXML printer to jar, because the Android manifest files that you're dealing with when you unzip these APKs are actually in a binary format, and you need to actually convert them back to text so that you can read them, okay? The other really big tool that's in the Android space in terms of hacking, reversing, and looking at APKs is Drozer. Drozer is kind of like, not exactly, but kind of like a Metasploit equivalent for the Android platform. You can put an APK file on the platform and you can communicate with that Android platform, be it an emulator or a hardware device, using a console, and you can send and receive Android intents. And intents is part of the free love society that is Android. When you send an intent, you're basically saying, hey, package file, run a process, do something for me. Or you're saying, hey, show me something in the logs, right? You're actually communicating inside of the Android system. Now, devices that can easily be rooted are very, very useful here. The Moto or the Google Nexus, I find the Nexus 6 is really nice for this, or the Motorola version of the Nexus 6, because the rooting kit that comes with, that's available for the Nexus 6 platform is incredibly reliable. You basically drop it on a Windows system, you say root the Android, and you're done. You get a super user package, you're good to go. And having SU, basically having that privileged shell inside the Android emulator or inside the device itself, is critical for you to be able to do your reversing and your hacking work. Okay? Nice to have tools. Genymotion is an extremely nice emulator for Android. Genymotion actually runs the Android platform as an x86 virtual machine on a VirtualBox instance. So Genymotion is kind of like taking a step up from the Android emulator that comes with Android Studio. Both the emulator that comes with Android Studio and Genymotion will run the platform as x86 code. And this is actually quite important because most of the phones you have in your pocket are running the platform on an ARM processor. Well, if you're running the platform on an ARM processor, most of the APK files that you're going to download for analysis, sidejacking, whatever you're doing to them, will not run on an x86 platform. However, your emulators run on an x86 platform. There's a challenge there. Now, in the case of Genymotion, there is a widely available translation library that can be loaded onto the Genymotion emulator that performs ARM to x86 emulation. So you still get the performance. In the case of the Android Studio environment with the AVD, that's the virtual emulator, you can actually run that emulator as an ARM processor. However, it is ungodly slow. It is so slow it'll take 20 minutes to boot up the graphical user interface on the Android device. So it's just unusable, all right? Or at least I found it's unusable on the OS X platform. Maybe on some other platforms it's useful, all right? Another tool that's really useful, I'm less familiar with, Derek can probably talk to it and will talk to it later in this talk, is MobSF, which is an automated mobile app assessment framework that runs with Android, iOS, and Windows, and does some dynamic static malware analysis. That helps you to automate. So these are some of the pieces, parts that we can put together when we're looking at hacking and reversing Android code, and for the most part, detecting vulnerabilities in that code, because you will find yourself, when you're looking at Android package files, looking from the perspective of a lot of reversing and source code examination, because frankly, that's the way you're going to find the vulnerabilities. It's much harder to actually poke at the app as it's running, although Drozer does give you a fair amount of ability to use intents and actually stimulate the app in a stimulus response kind of fashion. So both mechanisms are there. Okay? Configuring the emulator, we have to use Android Studio. We have to choose an Android to emulate. I generally will emulate a Pixel 2 or Pixel and Nexus variety. We have to choose an OS version. Now think about market share here. When you're looking at choosing the operating system version to emulate, think about what your target user group is going to be. Most likely, you're going to be somewhere between 6.0 and 8.0, more likely 6 and 7, because that is our Lollipop and our Nougat versions, which most of you are running, right? Think about the majority market share there, okay? SSL TLS traffic interception through a proxy, little trickier after 6.0. They've hardened. There's a war on SSL. I'm sure you're all aware of the whole war on SSL TLS interception, right? Becomes trickier, but the same concept applies here as if you're doing web app testing, right? You want to get the certificate onto the Android device, usually through the flash, and that certificate might be a certificate from Burp Suite Pro or other proxy that you're going to use, and then basically set up your wireless connections on the emulator or on the hardware device such that the proxy is configured in as part of the network connection. And then you get your traffic interception that you need. Okay? ADB is very, very useful when you're talking about Android hacking and reversing, right? I don't know why I have a funny thing about Courier font, but I'm always... Yeah, this goes down to the I'm older than the guys that talked earlier. Why Courier font? Because it's the only font. Right, Lee Neely? There we go. It's the only font, right? So I'm weird about that. Okay. We don't care about Courier font. Well, a little bit. ADB devices. That lists the devices that are attached to your system, your host system usually. In the case of OS X, it's going to be just command line from the terminal. Same thing with Windows, I assume. I don't hack it from Windows. ADB devices is going to list those devices that are serially attached through a USB cable, all right? If you've got a hardware device, or it's going to list the virtual devices that are running in the system by virtue of you running the emulator or Genymotion, all right? ADB root allows you to escalate, get privileges on that system, assuming that it has been rooted already. ADB shell gives you a Linux shell directly on the Android system that's running, which is very useful. ADB push and pull allows you to upload and download entire components from the Android file system, right? Most everything in the Android file system is going to be in the /data directory. So when you put packages on there, you're going to typically see /data/com.something.package name, and then everything associated with that APK package that's been installed. Okay? I can't give you all of the goods. This is like teaching an entire SANS course in 45 minutes. We're not going to do that. I'm just going to unload a bunch of things on you, right? ADB install allows you to sideload, right? Sideload and install Android packages. All right? How do you find your package files that you're interested in hacking and or reversing? Well, you go to some of these APK mirror sites that are outside of the Google Store. apkmirror.com, apkmonk.com. I find apkmonk.com one of the most useful ones that I've used, right? It enables you to search, find the APK, download the APK, sideload it onto the device, unzip it, whatever you need to do. By the way, just for your reference, an APK file is a zip file, just the same like a Microsoft Office file. So when you get it, you can unzip it and you can see its individual components. You can also read it when you get it with something like JADX GUI and decompile it, or you can read it with another tool called APK tool, which decompiles it into Smiley disassembled files. So there's a lot of choices we have there, right? You may be getting a package file directly from your customer. That's entirely possible. We have certainly done some malware analysis, done some vulnerability analysis and pen testing on APK files that we just get supplied directly from the customer, right? Now, how do we copy the APK file from a device? Here's a small example that Derek put together for us. We can do ADB shell PM list packages. That will give us a list of all the packages that are on an Android device. We can actually do ADB shell PM path for com.app.sumapp to find the full path, and then we can pull the APK file directly from the device. We can also pull an entire directory from the device where that APK has been extracted and installed. And that's actually kind of interesting, because what you find yourself doing when you're getting involved in Android analysis is you'll run the app once, and then you'll pull the entire directory, you'll run the app a second time and do something in the app, like exercise some sort of feature, pull that directory again, and then just use Unix diff, right? And look at what happened on the file system. Some of the common things that can happen on the file system would be, well, maybe the developer did something like used a SQLite database. Maybe the developer did something completely idiotic, like store a username and password in plain text in the SQLite database, right? By the way, that brings up another note. SQLite is very, very common in mobile apps, both Android and iOS. Very commonly used in the back end in terms of storing data, okay? Sideloading your APK, we use the ADB debugger. Just ADB install the APK file, and you've sideloaded that package onto the device. Trust me, I'm going to let Derek talk in a minute. I really will. All right.
I'm glad we took slides out.
Okay. What's your intention? Just a quick note on intentions. I talked about Android being kind of a free love society, right? Android intent is basically the messaging object that is used for lots and lots of things in Android. The way to think of it, it is kind of like the universal interprocess communications inside the Android operating system. You can use it to start an activity. What is an activity? Activity is typically that very first screen you see when you fire up the app. That's typically the main activity in the app. Okay? You can use an intent to start a service. You can also use an intent to deliver a broadcast message. For example, how does your Android system know that it just rebooted, or that the wireless service just got turned on, or the wireless service got turned off? The apps can actually subscribe to and receive broadcast messages from the system so that they can actually perform different activities, perform different services, different code paths based on the broadcasts that it's receiving. So any of these apps in the virtual machine, because it's a large Java virtual machine, can actually communicate amongst each other, receive intents, send intents to each other. It's just like free love in there, right? So you have to be very, very careful with the way you filter these intents. All right? What about our manifest file? Very common file in Androids is the Android manifest.xml. It's in all apps. It actually has requirements to declare the application name, declare all the components of the app. It includes a declaration of all the activities, all the services, all the broadcast receivers. It declares all the permissions that the app needs, such as I need the internet, I need to access your contents, your contacts, because all apps need to access your contacts, right? I need to access your wireless adapter. I need to access your Bluetooth because that's fun, right? Etc., right? Oh, hello. And it also declares hardware, software features that might be needed. So the message to you as an analyst, if you're faced with a mobile application assessment, is the Android manifest is the first thing you should look at, because it gives you a good lay of the land. It gives you essentially a map of the various portions of that app and what permissions are in that app that it needs to operate in the environment. And it may actually contain some malicious things, which we'll get to in a little bit. Okay? What about Drozer? Drozer is our framework for Android security assessments. Drozer consists of two components. One is an agent APK file that runs on the Android itself, and the other component is a console that runs on a Unix systems. Now, it can run on Windows, but it's most likely considered malware. Did you put that in?
Yes,
anyway,
because it's considered malware.
It's considered malware because Windows Defender considers everything malware these days. And it communicates over TCP via localhost, which is port forwarded, the default port, 31.4.15, right? The other thing about Drozer, it has various modules to examine the application itself. We can send these intents with Drozer. We can stimulate an app with a broadcast. We can stimulate a service by saying start service or stop service. We can actually send an intent to maybe enable some debugging functionality. That's interesting, right? So starting the Drozer session here, we've got an example, ADB forward, TCP 31.4.15, TCP 31.4.15 again. Gives us the port forwarding, and then Drozer console connect. Assuming that the agent is running on the emulated platform or the hardware device, you will then actually go into a Metasploit-ish console that allows you then to examine the attack surface, send intents, do all kinds of things. Here's another tool that you're going to use. I told you this is a giant survey, very quick talk, okay? Another tool that we're going to use is JADX GUI. This allows us to deconstruct the DEX files. DEX is the executable format that Java Virtual Machine in the Android uses into Java source. So it's actually decompiles the APK. The APK is zipped DEX files, brings them back to Smiley, and then decompiles the Smiley into Java source. Okay? So then we can actually search through the source. We're reversing the whole app. Okay? We can search through the source code at this point for interesting things. Things like intent communication. Things like dangerous network class use. For example, what if your Android app has a TCP client in it that connects to some odd IP address on the internet? It's probably evil. Okay? We can look at things like SMS manager use. It's amazing, like malware encoded SMS use in apps. I mean, they'll just like send a kind of like a command channel, right? They'll send something out to some odd SMS channel, and it'll say, hey, I'm here, or here's all of the contacts on this device, right? So you can look for things like that, all right? And at this point, I'm going to turn it over to Derek. That was super fast. What you got?
So all those tools, now we'll talk a little bit about how you go use those tools. So there's two frameworks for methodologies that I like to use, bounce back and forth between them. Of course, OWASP Mobile Top 10, we're not going to go through all of those because this is a 45-minute talk, and unless you guys want to stay until like 8 o'clock tonight, we won't have time. And then Joff mentioned the 6-day SANS course on mobile device. Josh Wright put together some report cards that sort of walk you through some important stuff with regards to the areas that you should look at. We're going to cover 3 areas because that's really all we have time for. There's some overlap between the two styles, but mostly they're approached with different goals in mind. So what should be tested in terms of like if you have a pen test? This is pretty much the OWASP Top 10. And for the sake of brevity, and also because a lot of this stuff, there's some overlap when you're testing, like certificate penning and things of that nature, we're only going to talk about a few of these things. When you have some insecure things, stuff stored on the file system, communication-wise, code level quality and tampering, which is actually really fun, and then also extraneous functionality. So just like a normal pen test or a network pen test, I like to start off with some reconnaissance. We'll call it app reconnaissance. And file system usage is really important in terms of how things are stored. Network communication, as you probably could guess, clear text versus encrypted. And then actually messing with the application, those intents that Joff was talking about. So Joff mentioned the manifest. There's some Drozer and ADB commands. I like to cheat. Does anybody ever take pre-calculus and then calculus, and you're in pre-calculus and you're like, this is really hard. Finding the area under a curve with these, this takes 45 minutes, and then you get to calculus and they show you the easy way to do it. It's kind of the same thing with the manual Drozer commands versus MobSF. And, I'll admit, I used to be a systems administrator. I'm lazy. I like to do my application reconnaissance with MobSF. So here's some of the ways you can list packages with both Drozer and with ADB. If you load MobSF, you basically drop the APK file in. It gives you the same information. And I use Strava here. I pulled Strava off of my phone, off my test phone. I just wanted to point out 175 activities. That is a lot of activities. Strava does a lot of crap. But when we talk about some of the apps here later, we're not picking on Strava because they have lawyers and stuff. And we don't want to mess with them. But so the other thing I really like about MobSF, I'll admit, it gives you some pretty stuff to put in a report for the client, right? But again, for application reconnaissance, sort of getting the lay of the land, it also does some of those decompiling steps, and you can also generate a PDF report to give to the client as like supporting data from your report. So insecure communication. Essentially, what we're talking about is whether or not the traffic is encrypted. And this is important, and this is something we'll see. We were talking about statistics earlier. So, Black Hills does, I'd say, last year we did 10 mobile apps. This year so far we've maybe done 15. It's a small percentage of overall tests, but it's still there's some common things that we found, right? And insecure communication is one of those. And what I like to do. Intercepting HTTPS traffic with burp is important, but I used to be a blue team person, and I really still like full packet capture. I can't help myself. If something's talking on the network, I want the PCAPs, right? So one of the things I like to do is set up a soft AP and capture all the traffic. And so there's a blog post that we did at Black Hills, Dave Fletcher did, that I use that and stand up a soft AP and have your device communicate through it, and then see if it's maybe not just using HTTP. Maybe it's using something else. And then for analysis, standard kind of stuff, Wireshark, TCP dump, and yes, Bro. I love Bro.
Because he's a Bro fan.
Yeah, I'm a Bro fanboy. And so Joff mentioned earlier, how do you go, or he mentioned intercepting traffic with burp. To get the certificate installed on Android 6 is actually pretty straightforward and easy. And later versions, it's a royal pain, actually.
Oh, look. Okay, we're going to pause a minute, and we're going to reveal some countermeasures. Dave has actually graced us with a Smirnoff Ice here. And we know this is, I am totally going to mess this up. Hang on. We know this is a tradition at Derbycon. Hold on while I get the countermeasures ready.
So normally I would drink it, but I'm not sure I really want to risk the interaction of while I'm up here talking, because I don't want to turn into a complete dribbling idiot, right?
Right. This is a chiller to bring it back down to temperature. Thank you. So I'm told by the Amazon advertising this will take about 10 minutes. But I thought, if he's going to play this game, I'm going to play back. Thank you, Dave. All right, we'll turn that off because it's really noisy. All right, we'll turn it down. Oh, turns out the three-way speed switch doesn't work at all. Okay.
Put it on the floor.
All right, put it on the floor. All right, careful, water. I did fill this up with ice.
And yet,
all right, we'll keep it going.
And the whole time I'm sitting here thinking, this is right above the laptop. This is a terrible idea.
By the way, I have a track record, I will admit, of destroying laptops by pouring drinks into them.
We have 3 company policies at Black Hills, and he's responsible for the one that says, do not put the beer next to your laptop.
It's true. True. There is a Security Weekly 10-year episode that shows me pouring an entire cocktail into a MacBook Pro. It was a very bad day because the smoke came out.
Oh, God. I think I should have went with the alcohol.
All right,
that's terrible.
Back to the talk now while we let this thing chill.
All right. So, insecure data storage refers to how things are being stored on disk, right? And I should mention this. It's hard to read, I know, but there's a session token right there in this post request. And I would just like to point out that same one was on disk on this app, right?
Totally on the disk, on the file system.
Just hanging out in a file, and I found credentials, I found plain text, passwords. So some of the things you should look for is basically lack of encryption, sensitive data that's being stored. Usually that's credential type stuff. And then, so how do you get at that? Well, ADB shell, Joff mentioned that earlier, and then just Linux utilities. I really like grep with some arguments, and the diff trick, that's pretty neat. So at that point, you're just kind of exploring the data directories. And I'm going to hurry because we're running out of time. This is actually this.
I killed it.
What the hell are you doing? This was actually sort of the beginning and the genesis of this talk. Like, hey, we want to put in a talk for Derbycon. What are we going to do? Well, we were actually on a mobile app assessment, and we found that the app we were working on, now it wasn't a banking app. I just want you to pretend that this was a banking app, right? So we found that there was an intent that we could send data to put the application into debug mode.
Actually, it was even worse than that. I just want to jump in here. Not only did we find an intent that we could send to the app to put it in debug mode, the actual library that was vulnerable was not written by the customer themselves. It was a dependency of the app, And so they didn't read the manual clearly, and we put this app into debug mode, and it revealed, what was that?
So what it started doing in debug mode was sending all of its network traffic, HTTP session information, to the Android log file, right? So in case you don't know, the Android log file is world readable on the device. So essentially, you could send an intent to this application and make it start logging sensitive information that any application can read on the device. So how hard would it be? Pretending this was a banking app.
I'll turn this off now. It's very loud.
How hard would it be? And do you think Google would catch if I wrote an app and sent this to this data and then took those post requests and just sent them off to my server? Is that malware? Is that malicious?
Yes.
Is that going to get caught?
No.
You know, there's what, 3 million apps out in the App Store? Probably not. And so we thought, this is really cool. We should probably talk more about Android. And so how do you do that, right? Well, you have to go dive into the code. You use that reconnaissance. You find the intents that are being called or that are being broadcast, and then you go look in the code for some terms, right? So you
specific method calls,
right? And then go read what they do and figure out how to manipulate it with Drozer. And so here's an example of how you could use a Drozer command to go and do that manipulation. And also, I'll have the slides up tonight. I'll probably have to go take a nap after this though, but the slides will be up for everyone.
Muscle relaxers are kicking in.
Yeah. And then we mentioned code level quality and tampering, which is a fancy way for messing with the application, right? So some of those things are. Or really the most important thing is sidejacking the app and recompiling it. And we have 10 minutes left.
I think it's time for me to do a sidejacking demo. Okay, so hey, the countermeasures worked well. It is much colder, so I'll come back to that in a few minutes. All right, so we wanted to end. This is really just a big survey talk, right? To give you a taste of the kinds of things that you should think about with mobile, all right? This stuff is not going away. We all know that the cloud is everything, and we all know that a tremendous number of platforms are migrating over to a very heavyweight back end and a very lightweight front end, of which mobile plays a significantly increasing part, right? So you need to consider it. You need to look at it, and you need to start setting up your labs and in your environment to make it part of your portfolio to be a well-rounded pen tester, right? That's the whole idea here of doing this talk. Now, I want to talk about an attack method here, and this is embedding a malware APK into another APK, okay? Turns out, right, of course, APK files are compiled Dalvik executables, or DEX files. There is another tool called APK tool, which I mentioned earlier, that allows you to disassemble, or backsmiley, as it's called in, I think it's Icelandic. I've not actually confirmed that.
So everybody who thought he was saying smiley.
Smiley, yes,
it's
smiley.
Smalley.
Backsmiley. Hey, I'll do the Australian version, all right? Backsmiley into assembler code, and then we can actually modify the assembler code and reassemble the package, which is kind of cool. Turns out that the Metasploit project, we love the Metasploit project, also has the ability to generate Dalvik executables as APK files to load onto Androids. And so you put 2 and 2 together, and you take your favorite APK file that you think your customer, or your child in my case. I love experimenting on my children. It's fantastic. They're adult children. I still love experimenting on them, right? You take your favorite app, you download it, you generate a Metasploit payload, you decompile both of them, you put all the glue back together and re-sign it, run the app. The kid feels like they're playing a cowboy shooting game when you've got an interpreter shell in the background and you're taking screenshots and you're taking photos and things, right? Fun, 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 right? Now, it turns out there are multiple really painful steps to doing this process. You have to download an app to Jack from APMonk or something like that. You have to generate the Metasploit APK file. Thanks to the Metasploit project, MSF Venom will do that for you. You need to use APK tool to disassemble both of them into Smiley. You need to copy the Metasploit stager code into the app that is being enhanced. And then we need to locate and adjust the main entry point. We need to adjust the Android manifest. We need to reassemble the newly edited code. We need to re-sign the APK file. And then we need to sideload or upload it to an Android and profit. And if you really want to be evil, publish it on the Play Store, right? We don't want to do that, though, right? We're the good guys, all right? Now, embedding malware. There's some hardware emulation challenges, which I actually alluded to earlier. The APK file is likely compiled for the ARM architecture. I told you earlier that emulators suck at running ARM code, right? They just don't really work. We do have libhoudini, which is the ARM translation library, so that can be installed on Genymotion, but they tend to be fairly unstable. I have found they are most successful with Android Lollipop around version 6. You don't really want to use them on more recent versions of Android. Okay, and that's not scientific. That's just me crashing apps over and over and over. Okay? You need a USB hardware attached device if you don't want to deal with the emulation problems, right? If you have a Moto 6 Nexus that you've rooted, you can just plug that in and do everything that way because that's going to be ARM and give you everything that you need, right? That's an alternative. Software challenges. Sometimes the APK tool has issues with resource files upon the rebuild, and it just bails out and gives you horrible errors, and you have to go into a manual discovery and editing mode to fix it, and it's very painful. So this is not necessarily trivial, all right? As in decompiling, well, we can just do a very simple command line, which is just APK tool. I almost fell off the front of the platform here. D-F-O, original for a directory, the APK files, and that will create a directory in both cases with the disassembled smiley code. All right, fully disassembled, ready to go. All right. Now locating the app entry point, where you have to go into the manifest, and I used this particular app. It's called com.cowboyshootinggames. Main activity is the main activity here. Went into the manifest file and locate this line, which is the intent filter that contains android.intent.activity main. Main is the key. That is the main application entry point. And this name field here is the activity that is launched as part of the app being launched the first time, right? That's the main entry point, all right? Non-trivial. Then you have to modify the main activity smiley file by searching for the onCreate method in com.whatever it is. The file is going to be essentially this file, com/cowboyshootinggames/main activity. And once you get into that smiley file, this is the disassembled content, and you have to insert a line to invoke a static assembler method here, which is going to be your Metasploit payload, okay? So this is actually non-trivial and actually subject to human error. That's what I'm trying to point out here. And then don't forget to copy all of the code from the Metasploit stage over to the APK, copy all of the user's permission and user's feature lines from the Metasploit APK to the enhanced APK, because you have to have all of Metasploit's permissions to do things like access the internet and access contents and send SMSs and take pictures, because it basically uses every possible permission that an Android has, right? All right. Then you have to reassemble and sign the APK. So basically reassembling and signing. Okay, I have abbreviated a lot of these steps, and there's a reason I've abbreviated them. One of the reasons is I have a blog entry on blackhillsinfosec.com that should be going up this week that describes this process with this exact game in much greater detail. So I will encourage you to follow the blog and read it when it comes out, all right? The other reason is I finally got to about this step after 40,000 different tries and frustrating, okay, thank you guys, and realized it's time to write a Python script, right? After all, I do teach the Python class for SANS, right? So I built a Python script, and at the same time, some of my friends on Twitter said, why did you just destroy all your Bitbucket repositories? Because at the same time, I migrated everything over to GitHub, because it was about time I did that, all right? So I'm known as Yoda66. I picked a handle. I'm one of these guys that never picked a handle. I was like, it's time I picked a handle. So I'm known as Yoda66 on GitHub. The project I built is called Android Embed It, and it basically does all those steps automatically, which is really, really sweet. So now I should do a quick demo. I know I've got very little time, 5 minutes, and we'll just do We're going to do live hacking here. You ready?
Here, hold my beer.
Hold my beer. All right. Quick demo. Here's Android embedded, running on Kali. Okay. Here's my downloaded APK file that I'm going to copy from once I learn how to type. The downloads directory, Cowboy Shooting Games, to my current directory. I've already pre-generated my MSF.apk with MSF Venom, okay? All right. I'm going to run my tool. Don't laugh, right? Little help here. The tool basically takes a few arguments. It takes an existing key store if you have one, and you have to supply a key name and a key password. It also takes an APK file and what I call an MSF APK file. So this was a very quick and dirty tool. It's written to locate the main entry point in an APK, to do that whole process, and specifically to embed a Metasploit payload, not any other, right? It's customized to Metasploit into the final payload. Turns out that I made it really easy for you. All right, here you go. Here we go. Hold my beer. You got my beer? com.cowboy something, msf.apk. And if you don't specify a key store, it will dynamically generate a temporary key store to sign your APK with. All right?
It's not fair when the demo is basically just a tool that you run. Like, you're supposed to go through all those steps.
If we had another 10 minutes, I would show you all the steps. Trust me, they're painful. All right? So there we go. We have a signed APK file that is now in this AE directory. It does all the work in this .ae directory, and it stores the malware APK, the original APK directory structure, generates the temporary key store, puts it all back together, and signs the file, and it's done. All right? Now we need an Android to copy it to. Bear with me, folks. I know I've only got like 2 seconds. All right? I've already copied it over to my desktop here because I did the demo here for earlier. That's my final APK. I'll copy it again just to prove it, right? That's from my VM. All right? Come on, come on, come on. Okay, this is not looking good. All right. ADB install my final.apk, and this is Genymotion running over here. It's an Android, okay? Now I jump into my Android and I find my Cowboy Shooter game, and because I'm really cool, I drag it to my desktop because I really want to do that, right? Here's my Cowboy Shooting game. I've jacked it. I run it. Look what I see, a Cowboy Shooting game. By the way, I haven't learned how to run this game. I have no idea how to use the game, all right? And look what happened over here. Nothing at all because I didn't check my networking. Okay, you'll just have to trust me that it works, all right? You know, live demos are killer. They're a killer. All right. Who decided to do this demo? Shall I try the? It was just working, I swear to God. All right. You'll just have to trust me, but it does work. Oh, we have 1 minute? Nah, let's stop. Let's stop for questions. All right.
While he messes with that, does anybody have questions? Well, we have a summary slide. No one really cares. Do you have any questions? All right. Well, come see us at the booth, and thanks for stopping by.